Well, hello everyone. Peace be upon you all. Welcome to the second stream where we read The Brain is an Inference Machine section, chapter 2, section 1, The Brain is an Inference Machine. The internet got cut and the electricity got cut, so that's why the stream stopped suddenly. If you noticed. Now we continue. Damasio, 1994, explains that emotions serve to maintain homeostasis in the brain through the chemical messengers known as neurotransmitters. Homeostasis is the biological tendency to find a neutral state of equilibrium. Hi, what's up? Homeostasis is the biological tendency to find a neutral state of equilibrium. The word stasis means standing still, and homeo means same or similar. This process relies on a feedback loop. The bird is making a lot of noise. One moment. Okay, he stopped finally. That was really noisy. This process relies on a feedback loop where current bodily states are monitored, observed, and then altered to bring the body back into balance. Most homeostatic processes in the body are unconscious, but emotions are linked to conscious awareness. For instance, when your blood sugar is low and your body needs calories, there is a series of chemical processes that give rise to the feeling of hunger. This is a conscious signal that you need to eat. It promotes behavior that ensures survival. Similarly, a rustling sound in the bushes at night will trigger a series of physiological responses: heightened senses, increased feeling of fear, and promote behavior such as fight or flight that are necessary for survival. What Damasio demonstrates is that emotions have their own feedback mechanism, so that an idea or image can generate physiological responses even in the absence of an external stimulus. Because emotional responses and conscious thought are closely linked, decision-making can be influenced by this emotional physiological feedback mechanism. Our thinking can go astray because we are afraid of bad outcomes, and that fear dominates a more rational calculation about which course of action is more beneficial. In addition to maintaining equilibrium, the brain also anticipates future events and circumstances by projecting likely scenarios based on a catalog of past experiences and concepts generated through social norms and social interactions. The process of regulation that prepares the body to anticipate future needs before they arise is called allostasis. Allo means other or different. I'm not sure I get it. Matthew Cole explains that emotions serve to maintain homeostasis in the brain through the chemical messengers known as neurotransmitters. neurotransmitters. Homeostasis is the okay. This process relies on a feedback loop where current bodily states are monitored, observed, and then altered to bring the body back into balance. Similarly, a rustling sound, okay. What the mass you demonstrate is that emotion have their own feedback mechanism. So that an idea or image can generate physiological responses. How's that homeostasis? Hello, Mr. Omega. I'm gonna speak Arabic a little bit. صاير إنجليزي. إيه الأخبار؟ So homeostasis, I understand the process that relies on feedback loop where current bodily states are monitored and observed and then altered to bring the body back into balance. Most homeostatic processes in the body are unconscious. For instance, when your blood sugar is low, your body needs calories. There is a series of chemical processes that gives rise to the feeling of hunger. So far, it is understandable. This is a conscious signal. This is a conscious signal that you need to eat. It promotes behavior that ensures survival. Similarly, the rustling sound in the bushes at night will trigger a series of physiological responses that correspond to the feeling of fear and promote behavior such as flight that are necessary for survival. I do not understand how it is homeostasis. The second example. I understand the sugar example, but this... What the Matthew demonstrates is that emotions have their own feedback mechanism, so that an idea or image can generate physiological responses even in the absence of an external stimulus. Because emotional responses and conscious thought are closely linked, decision making can be influenced by this emotional physiological feedback mechanism. Our thinking can go astray because we are afraid of bad outcomes, and that fear dominates a more rational calculation about which course of action is most beneficial. In addition to maintaining equilibrium, the brain also anticipates future events. Okay, this is allostasis. Psychologist Lisa Feldman Barrett explains that the brain stores neural pathways that are triggered by external or internal stimuli to provide the closest match to the current situation. The neural pathways form a kind of template of action promoting behavior like increased heart rate and pupil dilation or motion. Feelings are a goal-oriented response to certain situations. They prepare us to behave and react in certain ways that promote what is beneficial to the body and sharpen and shape our awareness of the world. In summary, the brain makes inferences about the world through perceptions, emotions, and concepts that are largely unconscious and deeply ingrained in our psyches. This process allows us to navigate fluidly and accurately through a world with so many and varied stimuli. Our reactions to stimuli are partially homeostatic, meaning that the body tends to bring itself back into an optimal state of equilibrium, and partially allostatic, meaning that the body prepares for and anticipates future situations. Together, these impulses construct a picture of the world that we experience seamlessly and dynamically. Our experience is far more complicated than the crude mental model we imagine. We are projecting and constructing the world we experience. We are projecting and constructing the world we experience as much as we are recording and viewing it, and that fact has important consequences for the kind of reflective and critical thought we ought to engage in when we try to think clearly about the world. But how is our mental how are we constructing the world we experience and projecting it exactly? By the homeostasis but it is a reaction. The homeostasis is a reaction. They have not clarified this point. Let's pass on. The evolutionary advantage of shortcuts. Human beings have evolved to navigate the world most effectively and efficiently by engaging conscious awareness only when necessary. For that reason, you can walk through the grocery store while thinking about what you are going to cook for dinner. You do not have to make way for you do not have to consciously think about where to go, how to slow down to make way for other people, or how hard to push the shopping cart so that it maintains momentum in front of you even as its weight changes as you add groceries to the basket. All that biomechanical activity can be outsourced to unconscious mechanisms as you scan your shopping list. The brain is quite good at engaging in habitual activities without the assistance of conscious thought. And that is a good thing because conscious thought is expensive in energy terms. Consider the picture that follows. Many inferences can be made about this woman's inner experience based on her expression and posture. While such inferences can be made quickly, they cannot be verified without further investigation, and they are highly susceptible to error, bias, and stereotyping. You are probably immediately able to provide complex inferences about this picture, such as the woman is worried, concerned, or anxious about something. The inferences you make about the image are easy, fast, and complex. They are driven by the kind of emotional and conceptual thought processes that are unconscious and efficient. While these inferences are quick and easy, you may also be aware that they are provisional without more information. Given more data about the circumstances surrounding this picture, you might revise your perception about what is going on. This is exactly the sort of thinking that drives the emotional projections discussed in the previous section. A different type of thinking is required to solve a math problem. The following example comes from the psychologist Daniel Kahneman's book Thinking Fast and Slow. Try to solve the following in your head. 24 by 14. That would be 240 plus 40 plus 8. Right? Be 240. No, not right. 240 plus 80 would be 220 plus 16 would be 336. I think that's the correct answer. Do you know the answer? For most people, multiplying two-digit numbers without pen and paper or a calculator is quite difficult. You might need perhaps 10 or 20 seconds of effortful thinking to solve the problem in your head, since you do not have the unconscious mechanisms to do so automatically. Stop screaming! Long-term Social and evolutionary pressures have shaped our brains to find efficient solutions to complex questions about facial expressions. The same cannot be said for math problems. Knowing the solution to a math problem may be useful, but it is not the sort of thing generally required for survival and reproduction. On the other hand, quickly reading other people's emotions is at times vital for survival. There are other interesting differences between these two kinds of thinking. While it is difficult to solve the math problem, once you solve it, you can be 100% certain the answer is correct. By contrast, it is easy to generate a story about facial expressions, but this story is highly susceptible to error, bias, and stereotyping. As a result, critical thinkers should be careful not to jump to the first most obvious solution. Energy demands on deliberate thinking. Solving a math problem requires rational thought and effort. When we engage in rational thought, our brains use up precious energy stores that may be required for the maintenance of the body. Because evolutionary pressures seek to keep us alive long enough to pass our genes to the next generation, we have a biological tendency to avoid effortful thinking. In a sense, it is evolutionary wise to be lazy. That's one rationale to think about it. That's one way to think about it. But I'm not sure. I guess they are right. In a sense. The resources demanded by conscious thought can be understood in terms of the familiar notion of attention. When a task requires significant attention, it places increased energy demands on the brain. Periods of high attention activity can be stressful as the body increases blood flow to the brain, delivering more glucose and oxygen for increased mental activity. Additionally, attention is limited and focused on specific tasks. Consider the selective attention tests developed by Daniel Simons and Christopher Cabris. Watch the video below and see how you perform on this test. Where is it? Oh.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count?
I think 9. It was difficult. I did not focus. I did not pay attention. An attention test. I did not pay attention.
The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Christopher Chabris and is copyrighted. It is available for use in talks, training, and teaching on DVDs from VisCog Productions. Learn more at theinvisiblegorilla.com.
Nice. I noticed the gorilla because I watched this video before. How many passes did you count? Did you miss any? I counted 9. Did you miss anything in the process? When our attention is focused on a novel and complex task, we become less aware of other stimuli outside the specific area of focus. Additionally, we may become fatigued, stressed, or anxious while engaged in paying close attention. Not surprisingly, our brains prefer automated shortcuts. Heuristics and learning. What's heuristics? Kahneman calls these mental shortcuts heuristics and rules of thumb for drawing inferences. Problem solving with heuristics is largely unconscious. Don't get it. Kahneman, I'm tired. I am hungry. I'm very hungry. Starting to lose consciousness and attention. Kahneman calls these mental shortcuts heuristics, or rules of thumb for drawing inferences. Problem solving with heuristics is largely unconscious, automated, effortless, and efficient, but it is not always correct. Rational thinking or computation requires conscious attention and effort, and we may not even be possible, and not we, why did I add we? And may not even be possible without some practice. We are forced to engage in effortful thinking when confronted with something new and possibly dangerous. We are forced to engage in effortful thinking when confronted with something new and possibly dangerous, or even with something slightly outside of our normal routine. For example, you have probably driven home from work to or school along a familiar route on autopilot, preoccupied with your thoughts. Maybe you have even gotten home and felt as if you cannot remember how you got there. By contrast, you have probably experienced the stress of navigating a new, unfamiliar city. In the first case, navigation can be carried out using easy, largely automatic processing, whereas in the second case, navigation requires the intense resources of active attention and rational calculation. Sometimes complex activities can become effortless, but unlike when we are on automatic pilot, such activities feel pleasant and fulfilling. When you become fully immersed in a complex activity to the point at which it becomes effortless, you have entered the state of flow. Flow states are possible only for someone who has achieved some level of proficiency at a task. They are characterized by intense concentration and awareness, as well as a sense of personal control or agency, but they are pleasurable because the challenge of engaging in the task is commensurate with your ability. By contrast, a novice may find the same tasks stressful and frustrating. This phenomenon can be illustrated using the notion of the learning curve that describes how a novice grows in proficiency. What this means is that a person may be able to rely on intuitions, gut reactions, and other automatic responses in a field in which they are an expert, but the novice should be skeptical of these methods of thinking. As a novice, your mental heuristics are frequently faulty, so you are susceptible to prejudice, implicit bias, and error. Consider the case of buying a car. Someone who is deeply familiar with the automobile market as either a buyer or a seller may be able to estimate the true value of a car easily, but the average person would need to do a great deal of research to arrive at a true estimate. Because of the effort required for non-experts to appraise car value, they are easily influenced by dealer incentives, marked up list prices, financing options, and other tricks of the trade. Given that we are all susceptible to these types of errors, it seems like a good idea to try to become more self-aware and critical and not rely exclusively on gut reactions or intuitions when encountering new material. Since you are probably a novice in philosophy, if you are reading this textbook, you ought to be suspicious of your gut reactions to and intuitions about philosophical questions. Keep an open mind and don't assume you already understand the philosophical problems you will encounter in the chapters that follow. Being open to new ideas and allowing yourself to admit some degree of ignorance are important first steps in becoming a better thinker. Heuristics and substitution in decision theory. The cognitive biases that we will examine in the next section are based on a more fundamental substitution heuristic. This term describes our tendency to answer a difficult question or problem by substituting it with an easier question to answer. While substitution often results in an incorrect or inappropriate response, it gives us a sense of satisfaction or cognitive ease in thinking we have solved a problem. For instance, when you are asked to evaluate something complex and uncertain, like the future value of an investment or the political prospects of a politician, you are likely to substitute that complex calculation for an easier one. In particular, you may substitute your positive or negative feelings towards the politician or the investment product. What product? Oh yeah, future value of an investment. But your feelings are likely to be guided by your preconceptions. When the brain defaults to heuristics that produce a less than optimal result or even an incorrect decision, it is operating with a cognitive bias. A cognitive bias is a pattern or a quick. When the brain defaults to heuristics that produce a less than optimal result or even an incorrect decision, it is operating with a cognitive bias. A cognitive bias is a pattern of quick thinking based on the rule of thumb. A person operating under a cognitive bias does not use logic or careful reasoning to arrive at a conclusion. Cognitive biases are like perceptual illusions. Just like perceptual illusions, cognitive biases are the result of the natural and ordinarily efficient operations of the brain. Even though mental heuristics often work perfectly well to help give us an estimation of reality without the mental effort required to generate a more comprehensive picture, cognitive biases are the result of the misleading and faulty patterns that arise from this process. Sorry, let's repeat this again, it's a long sentence. Even though mental heuristics often work perfectly well to help give us an estimation of reality without the mental effort required to generate a more comprehensive picture, cognitive biases are the result of misleading and faulty patterns that arise from this process. And here we reach the end of the stream. Thank you for watching. See you next time where we read Overcoming Cognitive Biases and Engaging in Critical Reflection. Thank you for watching and goodbye.